All right, recording is in progress. Go back and share the screen. All right, so we're here. Give you the quiz in just a few moments. I'm gonna go back and do some problems in 7.4 from the beginning. 1, 3, and 5, I'll knock those out. And how do you set them up? Some of you were asking how to set that up, so I'll do that. Then show you how to do something from 7.7. Probably end early to let you have some time to work on the quiz. Okay. And again, next Friday is our second exam. All right, so it's a chapter 7 exam. You're responsible for this material. You submit this homework. And there's a 70% homework requirement. That's pretty easy to do considering, you know, I do a lot of the problems anyway. Okay, so test number 2 is right here. Okay, so let's get ready for the quiz. So here comes the quiz. It's on the video, but if you want to take a snapshot, take a picture on your cell phone or a screenshot, that's fine. And here we go. 7.3 material. Okay, number 1, integral of x cubed square root of x squared plus 25 dx. Number 2 is the integral of x squared over radical 9 minus x squared dx. Okay, worst case, it's on the video. You can watch the video later. In fact, a lot of you aren't joining me synchronously here, of course, so then you have no choice but to do that. Okay, so this is all 7.3. You want to use this table, page 486, right? So pick the right one, either the first one, second one, or third one, and go from there. Work it out all the way. Work it out just like we did in class. No shortcuts. Don't make up your own way, but the way we did it in class. You'll have to draw yourself a triangle afterwards and do your SOHCAHTOA and so forth. Okay, so I'll leave it here for just a few more seconds. Get your screenshot and so on. Okay. And it's due 11:59 p.m. tonight. Open everything, open book, open note, open discussion, but you should do it in your own handwriting, obviously. Okay. So which of those 3 does this one fit? What's obvious, there's a plus. And the second one is there too. And for some reason, it seems to have paused here. So I have to stop sharing for a moment and go back in and see if that works. Okay. I seem to be having some problem with the screen now. Hopefully you saw it good enough. And I can seem like I can no longer share the screen. Well, hopefully you got that. This might take a while, or I might have to close the session and start up again. Well, in the meantime, you can go ahead and get started on the quiz. At least you got that underway. We were having technical difficulties, I guess is what they would say. I still intend on lecturing, so don't disappear totally, unless you want to, of course. But let me try to get this set up. But maybe you want to get started with the quiz while I keep trying to blab along here. Oh, there we go. I think. Yeah, okay. I think we're back in business. All right, so I'll put the quiz away and I'll go back and start lecture now. Okay, back in 7.4, questions 1, 3, and 5. Let me knock those all off. Okay, so number 1 was the easiest case scenario. Case 1, the denominator is distinct linear factors. Okay, so go back and discuss with you quickly what the cases were. Page 494, case 1, the denominator is distinct linear factors. Easiest case. Most likely on an exam, I'll give you something like that. Okay, so the denominator x, 2x minus 1, x plus 2. Just put x, 2x minus 1, x plus 2, a, b, c. And that's what this one is. So 1 plus 2x, 3 minus x, a plus b. That's all there is to it. Case 2, page 496. Q of x, the denominator, quotient. Product of linear factors, some of which are repeated. Repeated means squared or cubed. So notice x squared, they go x squared. X minus 1 cubed, x minus 1, x minus 1 squared, x minus 1 cubed, a, b, c, d, e. So 1b, 1 minus x over x cubed plus x to the 4th. Factor out the x cubed, 1 plus x. So x cubed goes x squared, x cubed. If it's at x to the 10th, you have x squared, x cubed, x to the 4th, 5, 6, 7, 8, 9, 10. And 1 plus x is all by itself, and a, b, c, d. Okay. 3. (3a), 1 over x squared plus x to the 4th. First, you factor out the x squared times 1 plus x squared. That says x squared, 1 plus x squared, or x squared plus 1. That is case 3. Page 497. The denominator q of x contains irreducible quadratics, none of which is repeated. So irreducible quadratic, you can't break it down. Irreducible quadratic, cannot break it down. So notice what they got. X minus 2 is as usual, a, but x squared plus 1 on top gets a bx plus c, and x squared plus 4 gets a dx plus e. So this is x squared, that's repeated. So a over x, b over x squared. And now x squared plus 1 gets a cx plus d on top. Okay, b, a little bit longer, you have to do the polynomial long division. Okay, the degree of the numerator has to be smaller than the degree of the denominator. So if these are both 3, you divide out so that this becomes degree 2 or smaller. So I set up the long division. X cubed plus 0x squared plus 0x plus 1. X cubed minus 3x squared plus 2x plus 0. Right? Anything which is missing counted as a 0 coefficient. Okay, x cubed goes in x cubed 1 time. Copy x cubed minus 3x squared plus 2x plus 0. Subtract. If you subtract, that's nothing. 3x squared minus 2x plus 1. So this quotient, that divided by that is 1 plus 3x squared minus 2x plus 1 over x cubed minus 3x squared plus 2x. Okay, so when it comes to integration, this is easy to integrate. 1 is easy to integrate. And this one, you'll do your partial fractions. So factor x cubed minus 3x squared plus 2x into x times x minus 1, x plus 2. Factor out the x, you have x squared minus 3x plus 2, and then you have that. Okay, and then once you have that, the setup is 1 plus, and then these are all distinct linear factors. So a over x, b over x minus 1, c over x minus 2. And there we go. Okay, then 5a. X to the 6 over x squared minus 4. You have to do the polynomial long division, right? That's probably the hardest part of it. Okay, so let me set up the polynomial long division for you. Okay, check the chat. How do you know when you have to do long division? It's asked if the degree of the numerator is greater than or equal to the degree of the denominator, then you do the long division like this. 6, 2, long division. 3, 3, long division. Okay. Here, degree 1, degree 4, you don't have to, it's all good to go. You need the degree of the numerator to be less than the degree of the denominator. So if they're the same degree, like they're both third degree, or degree of the top is bigger than the degree of the denominator, then you do the long division. Otherwise, you don't have to. Okay. So in this particular case, we have to do the long division. So x to the 6 is x to the 6 plus 0x to the 5th, 0x to the 4th, cubed, squared. They all got to be there with coefficient of 0. Okay. X squared minus 4. Okay, so I divide. How do you go from x squared to x to the 6th? X to the 4th. You now multiply x to the fourth times this whole thing. X to the sixth minus 4x to the fourth. Subtract. Gone, gone. 4x to the fourth. Remember, you're subtracting, you're not adding here. So it's 0 minus a minus 4. Bring down to 0x squared. How do you go from there to there? You multiply by 4x squared. 4x squared times that whole thing. 4x to the fourth minus 16x squared. Cancels out. Positive 16x squared. And watch out, you're subtracting, you're not adding. It's 0 minus a minus 16. Bring everything down. So what about all these missing things? You could bring it down or not. It doesn't really matter there. And then to go from x squared to 16x squared, you need a positive 16. So that's 16x squared minus 64. And remainder is 64, not negative 64. Remember, you're subtracting 0 minus a negative 64. So in other words, that divided by that is equal to x to the fourth plus 4x squared plus 16 plus 64 over x squared minus 4. Ultimately, we're going to integrate this, right? And that's easy to integrate. That's easy to integrate. That's easy to integrate. This when you do your partial fractions. Right? So x squared minus 4 is x plus 2, x minus 2, a, b, and that's about it. And again, stop. If we could find the coefficients of a and b, that would be case 1, the easiest case, but you know, that's not the purpose here. But once you find a and b, whatever they are, that's easy to integrate. X to the fifth over 5. That's easy to integrate. 4x cubed over 3. That's easy, 16x. And both of these are ln's. Right? Okay, and then finally, 5b, irreducible quadratic squared. So that's case 4. Find that for you here. Page 499. Q of x, the denominator, contains repeated irreducible quadratics. Okay. So let's look at this. Quick note, this is third degree. This is way more than third degree, right? So we're good. Okay, x, a, x minus 1, b. X squared plus x plus 1 is an irreducible quadratic, cx plus d. And now a repeated irreducible quadratic, x squared plus 1 is repeated. So x squared plus 1, x squared plus 1 squared, x squared plus 1 cubed, ex plus f, gx plus h, ix plus j. Okay, so what's it going to be in this particular case, right? So irreducible quadratic, ax plus b. Irreducible quadratic squared. So x squared plus 2, x squared plus 2 squared. That should not be equal, that should be a plus there. And then cx plus d, ex plus f. And there we go. All right, so that's it for 7.4. And now I'll do maybe just one problem from 7.7, the approximate integration. Okay, 7.7, again, I'm not doing any of the questions that were originally assigned. Okay, I made it my own. So 7.7's assignment is these. It's only 6 problems, but I say only in quotes. Each one you have to do 3. Midpoint root, trapezoidal root, and Simpson's root. So you're really doing 18 total problems. Okay, so they give me a function that we're approximating the area under the curve from A to B, and you chop each subinterval into so many pieces, 4 pieces, 8 pieces, 6 pieces, or whatever. Okay. So getting back to where we were, this is what you want to put in your cheat sheet, in my opinion. M stands for midpoint, T trapezoidal root, S Simpson's root. The geometric figure that you're using to approximate are rectangles, trapezoids, and parabolas. Okay. You don't really need to know that. I'm not testing you on that. I'm testing you on, can you come up with an approximation for the integral? Okay, this is very calculator dependent, so you want to have your calculator handy for doing all these problems. All right. Remember, if we were meeting face to face, I'd make you guys memorize these formulas. But for now, you can just put it in a cheat sheet. So I would tell my class delta x over 1, 2, 3. So midpoint trapezoidal Simpson divide by 1, 2, and 3. Okay, midpoint's easy. The coefficients are all 1, 1, 1, 1. Trapezoidal root goes 1, 1, and then all the in-between guys are 2, 2, 2, 2, 2. Simpsons goes 1, 1, and then in between 4, 2, 4, 2, 4, 2, 4, and 1. For Simpson's root, n has to be even. The only ones that we did had even ends anyway, so for these problems, you don't have to worry about it pretty much. Okay. All right, so I'll set you up with one problem. Okay, so number 1. Yeah, don't look in the back of the book for these answers. There are no answers that are there. We're estimating the integral under the curve e to the x squared from 0 to 1, and n is equal to 4. Chop it up into 4 pieces. In case you're wondering, you say, why don't I just integrate this? Simple. You cannot integrate this. Try as you may, you will not come up with a nice antiderivative for this, at least by conventional means. Okay? We have a strange way of doing it later on near the end of our course. Our last chapter, chapter 11. We are going to tackle this in some fashion, but I can't explain it right now. We'll worry about it when we get to it. Okay, midpoint rule you should already be familiar with. So between 0 and 1, they tell me n is 4. So I chop this interval into 4 equal pieces, which means what is my delta x? Well, I'm going from 0 to 1, chop it into 4 pieces. So delta x is 1/4, or 0.25. So 1/4, 1/2, which is 2/4, 3/4, 1. Okay. The graph happens to look something like that. You don't even have to graph it actually either. And then I take the 4 midpoints. So the midpoints are here, 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 and here. 1/8, 3/8, 5/8, 7/8. Right, halfway between 0 and 1/4 is 1/8. Halfway between 1/4 and 1/2 is 3/8. In fact, maybe it's easier to think in terms of eighths. Okay. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So my 4 midpoints are 1/8, 3/8, 5/8, and 7/8. All right, so M4, M stands for midpoint. 4 is the number of pieces that I'm chopping my interval up into. Is delta x over 1, which means you don't divide by anything. 0.5 divided by 1. Okay, and then watch how this 1, 1, 1, 1 stuff. It means give me the function values at the 4 midpoints. So f of 1/8, f of 3/8, f of 5/8, f of 7/8. Okay, so one more time. Midpoint root, delta x. You don't really have to write the over 1 if you don't want to, but it's delta x. And then 1, 1, 1, 1 means don't put anything in front. Okay, the 1 will become clearer when I do the trapezoidal or Simpsons rule. You see what to do. So f of the midpoints, f of 1/8, f of 3/8, f of 5/8, f of 7/8. Okay. Now you don't just plug in 1/8. You need f of 1/8. Means you plug into the function being e to the x squared. So e to these guys squared. So 1/8 squared is 1/64. 3/8 squared is 9/64. 5/8 squared is 25/64. 7/8 squared is 49/64. Okay. Punch all of this in your machine. Okay, I won't take up class time to do that. You can do it as well as I can or better. 1.448746. That's our approximation for the area under the curve for this integral from 0 to 1 of e to the x squared dx. Okay. And this is nothing new. You've seen this before. All right, so that was the midpoint root. Now, trapezoidal root and Simpson's rule, you do not use the midpoints. Just take the endpoints. Only one of the rows do you pick the midpoint. Can you guess which one of the three rows do you pick the midpoint? Midpoint row. That's, it says midpoint. So don't use a midpoint here. Don't use midpoint here. Just take the very endpoints, which means 0, 1/4, 1/2, 3/4, and 1. So trapezoidal rule works like this: 0, 1/4, 1/2, 3/4, 1. Okay. There are 1, 2, 3, 4, 5 endpoints. So for the endpoints, there's usually one more than for the midpoint. Okay. So in my calculation for the midpoint, there's 1, 2, 3, 4 midpoints, but there's going to be 5 endpoints: 1, 2, 3, 4, 5. For both the trapezoidal root and Simpson's root, there are 5 calculations, right? 1, 2, 3, 4, 5. Okay, above, I put coefficients to match this root here. 1 at the beginning, 1 at the end, 2, 2, 2, all the in-between guys. Again, the logic is, and you don't really need to know this unless you're curious, we are approximating the area under the curve with trapezoids, okay, like this. We don't pick the midpoints, just take pairs of endpoints and just draw a straight line segment here. And this pair go like that, and like that, and that. And you see it does a pretty good job of the area under the curve. And there's a formula for the area of a trapezoid. It's not 1/2 base times height, but it's 1/2 B1 plus B2 times height. In other words, you average the bases and multiply by the height. So it's 1/2 this plus this divided by 2, and then 1/2 this plus this divided by 2, and so on. That's where the half comes in the formula. And if you look at all the sides, all the in-between guys get double counted. The first one and the last one are only counted once. Right? So when I say this plus this divided by 2, and then this plus this divided by 2, well, this one got counted twice. And then this plus this divided by 2, this one gets counted twice. And this plus this divided by 2, this gets counted twice. This one gets counted once. This one gets counted once. Hence, 1 at the beginning, 1 at the end, and 2 for all the in-between guys. So the trapezoidal rule looks like this. Delta x over 2, 1/4 divided by 2, which is going to become 1/8. Half of 1/4 is 1/8. All right, now for these 1, 2, 3, 4, 5 endpoints, the beginning, coefficient of 1, the ending, a coefficient of 1. And yeah, you could say you don't really need to write the 1, which is true. 1 times anything is itself. And all the in-between points get a coefficient of 2. So notice it's 2 f of 1/4 plus 2 f of 1/2 plus 2 f of 3/4 plus 1 f of 1. So that's the meaning of this trapezoidal rule. Delta x divided by 2, 1 at the beginning, 1 at the end, all the in-between ones get 2. So 1/4 divided by 2, coefficient of 1 for f of 0, and then it goes 2 f of 1/4 plus 2 f of 1/2 plus 2 f of 3/4, and finally at the end, 1 times f of 1. Okay, then I plug into the function. The function is e to the x squared. Where did it go? E to the x squared, right? So 1 e to the 0 squared plus 2, 2, 2, and then 1. So e to the f of 1/4 is 1/16. 2e to the 1/2 squared is 1/4. 2e to the 3/4 squared is 9/16, plus 1e to the 1 squared. Punch it in your machine, 1.490679. Okay, that's the way it goes. Okay, so each question you use all 3 rules, correct? So there are quote unquote only 6 problems, but you're really doing 6 times 3 or 18 total. Okay. Are there units? Not for now. I mean, they're going to be square units, depending on the application. In a word problem, it might be square feet, square meters. But for now, they're square units because it's area again, but we're normally not putting it down. Just like all the other problems, we had volume of a solid revolution. It was units cubed, and so we don't put down the units unless they give it to us. Okay, Simpson's rule. Just like trapezoidal rule, except instead of delta x over 2, it's delta x over 3. And it goes 1, 1, and 4, 2, 4, 2, 4, 2, 4, and so on. And it only works when you have an even number. Okay. So here's Simpson's rule. 0, 1/4, 1/2, 3/4, 1. So notice all of them were doing 0, 1/4, 1/2, 3/4, 1. Now, how come the midpoint rule got more crowded? That's because I had to put the midpoints. So, when should I get the midpoints? Midpoint rule. If I'm not doing the midpoint rule, do not use the midpoints. So the picture is a little bit cleaner. You have 1, 2, 3, 4, 5 endpoints. Okay. Simpson's rule used the same 5 endpoints: 0, 1/4, 1/2, 3/4, 1. Only difference is 1, 4, 2, 4, 1. Right? So if you do it the right way, the second to the last one is also 4. That's the result you would get if your approximating shape is parabolas. Okay, the book goes over the heavy duty math for that. I'm deciding not to show that to you, but just take it by faith that that's the way it works. Just take 1, 4, 2, 4, 1. And instead of delta x over 2, Simpson's rule is delta x over 3. So 1/4 divided by 3. And you're using the same 5 endpoints: f of 0, f of 1/4, f of 1/2, f of 3/4, f of 1, except instead of 1, 2, 2, 2, 1, it goes 1, 4, 2, 4, 1. So 1/4 divided by 3 is 1/12. So it goes 1 e to the 0 squared plus 4 e to the 1/4 squared plus 2 e to the 1/2 squared, function at e to the x squared, plus 4 e to the 3/4 squared. And once I reach the end, the coefficient is 1, 1 e to the 1. Punch into your calculator, 1.463711. Okay, they're all pretty close. 1.44, 1.49, 1.46. Which one usually does the best job of approximating? Simpson's rule normally does the best job of approximating, because you're approximating with curves. You normally start off with curves, right? Midpoint rule, you're using rectangles, not curved. Trapezoidal rule, you're using trapezoids, not curved. Simpson's rule, you got curves. So it usually does the best job of approximating. Okay. So one more time, and I was actually going to quit after this. I was going to show you more on Monday, but I want you to have time to start working on the quiz. Okay, so midpoint, trapezoidal, Simpsons, delta x over 1, 2, 3. The midpoint rule is exactly the same as the midpoint rule you had in Calc 1. Just take the points in the middle, right? Function values at the midpoints, 1/8, 3/8, 5/8, 7/8. Trapezoidal rule and Simpson's rule, you use the endpoints. Okay, so 0, 1/4, 1/2, 3/4, 1. Simpson, same thing, 0, 1/4, 1/2, 3/4, 1. You do not use the midpoints. Say, when should I do the midpoints? Midpoint rule, right? The others you don't. Trapezoidal rule, delta x over 2, 1, 2, 2, 2, 2, 2, 1. Simpson's rule, delta x over 3, 1, and then it goes 4, 2, 4, 2, 4, 1. Punch it in the calculator, and there we go. Okay, obviously I save time by not spending class time to punch it in the calculator, but you want to verify that you can do this yourself on the calculator also. Okay. Is the quiz on 7.3? Yes. Just that material. Okay, and I was going to stop there, folks. Unless anybody else has any questions, I was going to quit and let you work on the quiz. Do it 11:59 tonight. So I've only shown you one of these. Question number 1. So Monday, whoops. Monday, I'll do a couple more of these for you. And then I would have done 3 out of 6, I guess. That would be good enough for them. Okay, so all we have left after that, so schedule-wise, I think we're okay. Finish up 7-7 on Monday, 2 days for 7-8, review for the test, and then test on Friday. Okay, all right, I'm gonna stop the share and check if there's anything else in the chat. And if not, then I'll turn you loose to get started on the quiz. Okay, so let's see. All right, anybody else with anything? All right, so we're done, folks. So have a good weekend. Turn in the quiz by 11:59 tonight. All right, have a good weekend. See you, everybody. Bye.